So today I will be talking about GraphQL. I will be the only presentation, so it will be not such a long Techfrulle. The reason I'm talking about GraphQL is because I'm a web developer and I work with APIs a lot. And GraphQL is simply a way to do APIs. And I was really interested in it, and I really wanted to find out what it's about. So I just use this opportunity to talk about GraphQL, to learn GraphQL. So I'm in no way an expert. I'm just the guy who just tried it out, and I was going to tell you what he found out about it. So let's start with a little bit of really short history of web development and myself. So in 1995 I got this book on the left side from my father. It was really nice because internet used to look like GeoCities a lot, but this book actually had some really cool examples from the States. And it's around the same time I was like on a holiday in Spain, so you see I was both invested in my future and suicidal. And you would have these kind of like things always on website. I thought I found those on the net and was like, good memories. So in 1990, basically, a website was served statically and you had to sort of refresh to get a new state. I see all the things are, oh, now it works, right? Ooh. So yeah. And then this thing happened. It's like a marketing term got slapped on the web, Web 2.0. I don't know if you remember that or if you were even born. But not looking at you, Mark. Oh, looking at you. Anyway, what happened then is basically that websites were able to start calling back to the backend. This became a very normal thing for websites to do using Ajax, and Ajax even has a logo. I think that was pretty funny. I didn't even know that. It's not such a deep concept, but because it got so popular, websites like Gmail arrived, and those really functioned like applications in the web. That was a new thing. And then in 2007 we got this whole new revolution, the mobile revolution, and this made that we even had more stateful clients. Maybe we had clients that were on versions from 4 years ago because it was used by some woman who doesn't want to change their phone every more than 4 years or whatever. Or she cannot, there's no space on the phone anymore, so she's stuck on this old app or whatever. So the problem in the 1990s was just being able to serve a website, and by the time it was the end of the 2000s, it became a problem of dealing with a lot of different clients and serving data through APIs to those clients. I've never really worked with SOAP, so I don't know anything about SOAP. Tim talked with me a bit about SOAP, but it seems it's mostly used in enterprise. I've never encountered it really on the web. I found that Twitter has a SOAP API. That was sort of the only one I could find with the common web giants. And basically the rest seems to use REST, or REST, a version of REST, because it's not really clear what REST exactly is. It's really simple to learn. That's, I think, why everybody uses REST, because it's such a simple idea. You use the tooling that they were already there. It ties into HTTP often, which by the way is not in the REST definition, but it seems that is how everybody uses REST. And it doesn't offer much structure, so you can basically apply your own. So you can basically do whatever you want, and it will work. People can interact with it, and they can start using your API. A thing about REST is that there's this convention where URLs resolve to one type of resource. So for example, if we want events, we would get events, and if we want a specific event, we do get event /ID. But the thing is that that means that if I want to have talks, but I only know which talks I should get when I know the speakers, and I only know which speakers I should get when I want the events, it means I have to do 3 sequential requests that have to wait for each other. If you're sort of next to the server, that's not an issue, but because of speed of light, doing these back and forth trips might actually get really take a while before they all get resolved. And this is a real issue with REST, is that because it ties in with HTTP, and it has this philosophy of sort of one resource per URL, at least that's how it often works in practice, you get you have to do a lot of management of these like sort of waterfall requests, and you have to stitch the results together, and it actually might be not so performant at all. And this is a trivial example, but imagine having like 10 different types you need to have before you can show a page. Yeah, this is basically what I just said. And as a solution, you sometimes, if you're very diligent, you don't do this, but I've seen it a lot, is that when you start overloading your endpoints. So you say like, well, I want to do one call so that I don't have to like go back and forth 3 times. And because the server knows already what speaker IDs and talk IDs are there, right? So I don't need to like query on the front end. I can just like get the server have me return that. And then you get this sort of like more RPC kind of API where you basically tell the server what to do. And in this case, include speaks and the talks, but then you have this like one version of your app which shouldn't get users because the user objects in the speakers, they're really big for some reason. So you say, I'll exclude those. But for the web, it's fine because the data connection is better there. And then, at some point, somebody starts like, I don't know, iterating on this endpoint and like adding stuff that's not interested for the old one. So they add versioning. And, somewhere down the line, the product owner really wants to add a summary. And then, and this just keeps going. And you really need to be super diligent about like not making sure this happens, and you need like the most senior people in your company to like make sure you don't have to resort to like basically redoing your API. It's really difficult with REST to manage that in a good way. And so that means is basically when another downside of this, by the way, is that you get this sort of tight coupling between client and server, because like the server is like preparing the data and like exposing all kinds of sort of like flags and like features that are specific to particular views and clients. So you imagine like that I need something for my new version of my mobile app, and I need to go to the backender, and he's like, okay, so you need this data in that shape, and and how do I do this? Okay, I'll just like add a thing here. But like I come with a request specifically about my view, and then next week I can come with a different request about a different view, and it's like you get all this like tight coupling between what the data looks like that's returned and how it's presented in the client. And that's in general, of course, not a good idea when you have tight coupling between these kind of systems. So it's simple in the beginning, scaling is a pain in the ass, and it has more issues, but I'm not going to go into that. So Facebook also realized that there are a lot of issues scaling REST, especially on like dealing with many clients. So they invented GraphQL, they open sourced in 2014. In 2015, this is when I saw a talk about it, it said we're serving 250 billion requests a day through one GraphQL endpoint. That's quite a lot. I mean, that's a serious amount of throughput on one endpoint. But I think this is even more impressive. 1,000 active clients. So they managed to have an API that is capable of having 1,000 different versions talking to it. Different versions of like mobile clients, web clients. I don't know what type of clients they have, but there are 1,000 different active clients. And I think that's really impressive. And that really shows that, for me at least, that GraphQL is an interesting technology to get to know more about. And today I will sort of explain like what it is and like how you can use it and la la la. It's actually really simple. So this is GraphQL. This is sort of how it works. So on the server, it defines and exposes a schema. And the schema is then exposed like over HTTP, but that is common. Like GraphQL itself doesn't say anything about your transport layer. Like it's like agnostic about it. The client sort of gets this schema, and based on the schema, creates a query. The server gets this query, validates whether it's even a valid query, and then resolves the query into a response, and then sends it back to the client, and the client consumes the response. So this is how like that works normally. And you can see a bit like this, is that in the middle there's GraphQL, and you could also draw REST there because it's sort of in the middle. It's an API, right? So it exposes sort of services in a structured way. But the big difference here is that you see that there's different transport layers here. Like it doesn't really matter where the client comes from. If it gets access to this GraphQL thing in some way, that's fine. Like GraphQL is not tied into HTTP like REST often is. So I even added like process here because you could have like a process on the server also talking to GraphQL via ICP. that doesn't really, like, there's no restriction. So to rehash, GraphQL is agnostic about almost anything. Like, it doesn't say anything about which database you're using, which language you're using, which server stack, which client stack, la la la. And basically, it's a protocol. So like, there's different implementations for different languages. But as soon as like there's a protocol implemented, that means that clients can then start interacting with it. And those clients, of course, can have their own languages and own implementations. So like, these are the languages that have server implementations. I will use JavaScript because I'm most familiar with it, but you actually probably will be able to follow along because we're all used to sort of C-like syntax, and JavaScript is like that. So how does it work sort of when you consume GraphQL? Data you work with, likely, like I said, is like, it's, you know, the data we work with is likely relational. I mean, there's some people maybe working at clients where they have a ton of big data, and maybe that's less relational, but when you make applications for end users, it tends to be quite relational. And to give you an example, this is like, this is the sort of UML graph of GitHub. So what GitHub did, they moved their entire API to GraphQL, which I think is really cool, but also allows them to use some tooling such as this visualization tool. And this shows like, for example, if I would go to commit, it shows like all the sort of incoming connections to a commit type. But if I would go, for example, to a git actor, which is basically then a user, you see like a user really has like a lot of things related to it. So this is, I think this is like, I don't know if this is useful, but it at least shows that your domain can get really complex. Try iterating on this. Try to like make sure that you know, people will have, even though they're on an old client, it still works. And GraphQL is basically created to make that particular thing easier. And I think that's because types and relations are first-class citizens. You know, I'm used to JavaScript and not having typing, but with data, that's actually super handy. That you know sort of like what's the relationship between a user and a blog post, and that it's explicit and it's not like something you have to derive because it just looks like something. So there's very little duck typing in GraphQL. And types, so you always know what fields you can expect and what types those fields have. That's really great. So if I would give an example, throughout this presentation, we're just going to work with Techfrulle data. So basically, added speakers, events, and talks. Today we have an event. There's one speaker, me, and we have one talk, but you know, we've had a bunch of them. So I figured this is nice relational. They all have relations between each other. And I just, like, as an ample data, it's a very trivial example, but you can imagine how it scales. So this is how a query would look like if I would want to query against this data. This is how a GraphQL query looks like. It doesn't look like any query I've seen before I saw GraphQL. This more looks like some sort of JSON object without quotes. But anyway, it says like, I want an event and I want the first one, and then I'm interested in the date field on that event. So a response from GraphQL would look like this. And that's immediately, you see here, one of the big sort of like upsides for API consumers is that your query looks exactly like your response, or your response looks exactly like your query. So it's really easy to understand the relation between those two. Compare that with SQL, for example, where it's much harder to derive that. So I get only the date also. So I don't get anything else, and I don't get anything less, because I asked for the date field, I get the date field. I didn't ask for ID field. If I wanted confirmation that that's ID1, I should have added ID here as well. But what if you want to like query a relationship? And it works exactly the same way. Like, relationships are just like fields that on other entities. So like, if I want to know which speakers presented at the first event, I literally just add like a key speakers, and I say, well, I'm interested in a name. And of course, there were multiple speakers. The schema defines it as a list, therefore it's an array. So it doesn't exactly look like it anymore. but the idea is the same. Basically, now I get objects, and for each object I get a name. So this is basically how like GraphQL works on the consumer side. And you have a lot more like tooling and all that kind of things, and we'll go through a little bit of that as well. But the concept is very simple. It's basically you make queries and they get resolved to responses. So you could say almost is that the hard part is in the server, because this makes it very easy for the consumers. The problem literally gets pushed to the backend. On the backend, or on the GraphQL server, well, I say, because a server it could be on the client. It could be on the client. It's just a GraphQL server. You create schemas, and these schemas define the shape of your data and how data relates to each other. So you have these basic types. I see like a lot of them fell off, but you have int, float, string, boolean, ID, which is basically also a string, but sort of communicates that it's non-human readable, and surely another one. And then you can like define that it should be a list of things. Like for example, this is a list of integers. And you can also define that like a type is required. So that, for example, when you query for something, it's always going to be there. Like a user always has an ID. If you want to indicate that, then that's indicated with an exclamation mark. And you can think a little bit about what that Boolean thing means then. It means that like it's a list of Booleans, and the list should always be there. And there should always be at least one Boolean in there. So if you would, for example, remove the last exclamation mark, it would mean that there might be a list, and if it's a list, it has at least one Boolean. And if you would mean the first exclamation mark, it means there's always a list, but sometimes that list is empty. But if there's a list, there's a Boolean in it. If the list is not empty, there's a Boolean in it. Of course, this is like just the basic stuff. These are like the leaf nodes of your graph, I would say, but you compose things with your own types. And in this case, just 3 simple examples: talk, speaker, and event. So basically, this is what a schema looks like then. This is a user, and a user has an ID, and it's like it's like always there. The full name is not always there, but if it's there, it's a string. And hobbies, it's the array. You always get an array back when you query it, but it's not always like filled with hobbies. Like sometimes it's an empty array. So when on the server, when you query for something, when the schema gets exposed and the server then gets a query that it needs to resolve, it has resolver functions, and these map to the types in the schema. So you see exclamation mark user, capital user there. So these get matched by the GraphQL engine, and here you can basically put anything. Like you can put anything asynchronous, so you can talk to database. You can like maybe fetch something synchronous, like in my examples later, or you maybe can like fetch something from another REST endpoint. You can, I don't know, you can do whatever. Like that's the thing. That's what I meant with it's storage engine agnostic, because you write these resolvers. You are responsible for determining where data comes from and how it is resolved.
And also making sure that it's explicitly the way you explain with, strings. It has to be a string. It can be a string, but an empty array, for instance. So you have to take care of that yourself.
Yeah, but if you don't return the type in the right, or the data in the right way, you will also get an error.
Oh.
So you won't just dump it on the user, deal with it.
I have a question,
Mm-hmm.
but maybe you will get to it. Regarding the schema, is it possible to have more complex schema, like saying the full name should be of a certain length or regular expression?
Yeah, I don't think so, but maybe. Okay. Because it's not something I encountered yet. Yeah. So they're like, it doesn't do all validation. Like
I'm thinking about the input for the queries.
Yeah, no, I think it's just like, no, I don't think so. Okay. You would need to write that, you would still need to write validation logic. Okay. Yeah. Some of it will be handled by GraphQL. this is the obligatory hello world example. Basically, we build a schema here. The way sort of that works is that like GraphQL, when you start a GraphQL server, which happens here, you pass in the schema. But you always have this a high level concept where you say that what are my entry points into what can I query for, like on the highest root level. Like you saw earlier that I was querying for event, for example, and this allows me to query for hello, which so it's an hello world, so it's always a bit weird, but you can query for hello, and when you do that, this is a query, right? So here, query hello, you query for this thing, and then this GraphQL engine, it will actually validate that there even is a field hello. If there isn't, then you would get an error. So there is some sort of validation. So this query gets actually built into an AST, and this AST is run against the schema, and if it doesn't match, it will just reject it. But if it does match, so what then happens is this resolver gets executed, and you see hello matches this field here, and therefore this resolver is executed. This is a function which stores a string, and therefore if I would run this, which I'm going to do now, you get data hello world. So it worked. The interesting thing I find is that there was no single like network call involved here. This was just like it ran from there to there and it was done. So there, like GraphQL, you can run it, like I said earlier, it's agnostic about your transport layer. You yourself have to make work to expose this then over the network. But, I'm slightly lost now. Yep. However, like I said earlier, there are server implementations for GraphQL, so you don't have to do that work. Like this is open source, the open source world, right? So like almost any sort of like interesting backend has, or a language has a GraphQL implementation now, and also something that then can expose it over the network. In this case, there's one that ties into Express, which is like an HTTP framework for Node, and it's sort of like a one-liner here. Like you say, like, okay, on this endpoint GraphQL, I want to run this expose GraphQL as a server, and then you pass in the schema which we defined earlier. We pass in the resolvers, and then there's this other interesting thing which is GraphQL, which is sort of like a tooling you get for free with this package. And basically allows you to get an interface in the browser where you can interact with this GraphQL endpoint. And I only run it in developer mode because I don't want people in production, starting to query things against my server. So if I would run that, then this is like going to this URL you see there, GraphQL, the GraphQL route, and this is like the GraphQL interface. You don't have to use it, you can use curl, but this is kind of nice. So if I would, I can just type my query here, and you see it automatically, it's sort of like does code suggestions. So when I do hello, and then I run it, it returns hello world. It's very simple. So we'll be using this a little bit in the next examples. So let's talk a bit about like this data set from Techfrulle. So we have speakers. Speakers have like IDs and names, and I made this poor man's database where you have a lookup, so I can just like go in this array and look up by ID. And this would be the schema. So a speaker has an ID. It always has an ID and has a name. Sometimes a name you can query for it. It's not guaranteed to be there, but if it's going to be there, it's going to be a string. And then there's a query, which means it's like the schema exposes the ability to query for speaker. And if I want to query for speaker, I have to provide an ID, and I will get back a speaker. And this is resolved by this function, and basically just get speaker by ID. But this could have been like a SQL interaction with some database. So yeah, so there now I got some extra things. So basically, there's docs here. So this is really handy because like the schema that I just defined is also exposed like as a way, as documentation sort of, so I can know what I can query. So in this case, it says a speaker, I can query for a speaker, it takes an ID and I get back a speaker, but what is a speaker? Oh, it's an ID and a name. So this is kind of handy when you start like interacting with the GraphQL backend. You have this like documentation comes out of that GraphQL endpoint. Like it tells you what it can do. So if I would want to query it, I can type query like this, but I actually can leave this away. So in my examples I won't use it, but I want to use a speaker, and I have to provide an ID, which is for example 4. And I get back a speaker. So what does a speaker look like? Oh, that's an ID. Well, I'm just interested in a name. Oh, it's Birgitta. That's how that works. And if I want to add ID or something, I already know it, but yeah, you get it. So let's add some more data, events and talks. They have a certain structure. That means our schemas get bigger. We have an event which then composes actually both talks and speakers. So you see that an event type actually has a reference, a relationship to talks, multiple. There's always going to be like a list, an array of these things, and sometimes this will be empty. But if it's going to have something, it's going to be a talk. Same for like speakers. And then we expose these on the root level, so that I can query for, just like I could query for a speaker, I could query for a talk and an event. And the way sort of like this nested, or this the way like types, fields that are actually other custom types are resolved is also is done like this. So you say like for the talk type, the speaker field would be resolved like this, and the talks field and event is resolved like this, and so that's how that works. And what I also wanted to do is I wanted to have 3 more endpoints or entry points on the root level, which is like speakers, talks, and events. So I can basically query for all speakers and all talks and all events. And that's also really simple in this case, at least. Trivial, the resolvers is basically get all speakers, get all events, get all talks. So now we have here, see we have some extra stuff. So we can say like, well, if we would want to say speaker oh, it's Henrik. So Henrik is the 5th speaker, or actually 6th, it's a 0 based. But if we want to know, like, so what did he talk about? We know that we have this, if we go to speaker, we just got a speaker, we know it has a relationship to talks. So we can actually say like, okay, so it's like, okay, these were his talks. But if you go to talk, maybe you want to know, like, we have this view in our front end or whatever where we want to show what other like talks there were at which this user or speaker was presenting. So then, but we also want to show his own talk. And then we can like maybe just say like, well, at the event he was presenting, which other talks were there and which were the speaker and what was the title. So, and then this is the data, like Johan presented also with AWS partner portal thing, and LinkedIn on the first one from Birgitta. So this like it allows me as an API consumer to really interact with an API in a very discover the way I can like find the data that I need, and this is a very specific thing, right? I didn't have to once interact with a backender to get this done. As soon as he exposed these types, these 3 basic types that we have, and also like made the relevant entry points for them and hooked them together, then suddenly I was able to make this this query myself. So this is like basically how you would like query. Of course, like we also do mutations, so creating, updating, deleting. This was pretty baffling to me, but mutations look exactly the same as querying. It's like the same concept, and so it's also types. Like I was like, okay, how can a mutation be a type? But that once you get used to it, it really makes sense. So you see here first there was on the schema there was a query field, but now we actually have a mutation field, and this is a mutation type, and this type has one field, add speaker, and it takes one argument, speaker, which is of type speaker input, and it always has to be there, otherwise it's not gonna be able to run. And a speaker input is just a type, but the only thing it has is a name, which should be there, and it's a string, and it returns a speaker. And that's interesting about GraphQL. It's like every field, even if it's a mutation field in a mutation type, has to return something. And because it returns speaker, I can now, for example, I add a speaker and I get back maybe the speaker that I added. Like that's actually really handy. So that for example, I add a speaker and I get the speaker back, and then I can sort of get which ID was created for that speaker, or maybe some other fields that are interesting to me. And the resolvers are like, therefore, they work in the same way. And a mutation resolver has to both create a side effect, like create a speaker, but also has to return that speaker. And in the same way, I add also for talks and events. It's the same concept. So if I would go, oh yeah, by the way, there's all this history here on the side, so you can run through your previous queries. It's kind of handy. So if we would say is that I want to add myself because this thing doesn't contain me yet. And since it's now almost finished, this talk, I can do that. So add speaker. It takes a speaker, but what is a speaker that has type speaker input? What is that? Oh, it's like a, I have to provide a name. But it returns a speaker. That's nice. So then I can like figure out what the ID is. Oh, yeah. For mutations, you have to add the word mutation. So now I know, like, oh, cool. I got added as with ID 9, which is true. If I would like then clear for all speakers, and I would see that I'm ID 9. So then if I would want to add myself to as a talk, I have to first add talk. It takes a talk input, which is title. Motherfucker. What was it? 9, right? So, oh, and I get back a, what do I get back actually? I get back a talk. And a talk.
Speaker line, not ID 9?
Let me see, good question. We go to that talk and it says speaker. Okay. This should be a ID, by the way. Because now you're like, what's this? But it should be an ID. But it doesn't matter because it's still strings. Anyway, I get back a talk. So it's nice maybe for Node to know what's the ID of this talk and the title. And because the speaker, I get back a speaker, so I would be able to query directly on that as well. So I can say speaker name, and then I, oh yeah. So now I added the talk by simply just saying like a title and a speaker, but because I get a speaker type back, I can also treat it so I added the talk and I get a talk type back, I can then really fully interact with that type as if I were just querying for it. Now the last one, adding an event. It takes an event. I know that, but what exactly looks like I keep forgetting. So that's kind of handy. You can just see it here. Event input. It takes a date. 18 and talks. Thank God we listed the ID. And because we get an event back, yeah, I can do the same thing. I can just for this event, who were the speakers, what were their name, and did they have talks, and for those talks, what were the titles, and which event was it at, and you see that I start looping. Oh, an hour. I guess that happens. So this is basically how that works. So the power is in like that you can like, even when you do a mutation and it's like it's strongly typed, you can, because it's strongly typed, you have so much freedom. So it's really interesting for me as a JavaScript developer, where I always figured like, oh, you know, loosely typed is so handy, you have so much freedom. But the first time I really worked with a strongly typed system, and I get more freedom than I've had before. So basically we are at the end now. What we didn't cover a ton, right? So this was just an introduction, super basic stuff. You were probably like, well, errors, how do you do errors? Or how do you do filtering? Or quite interesting, how do you make sure you don't blow up your server? Because this just seems like sort of dynamite. Anybody can query for anything. You know, there's a lot of concepts there. And I think what the nice thing about GraphQL is that it's such a small basic concept. There's almost nothing to it. It's like a protocol, and you have to write your own implementation for your language, and they're not gonna like add like a ton of API things. They say this is like a super basic thing, and what you see then is that the community starts building their things on top of it. And there's been some like frameworks like Relay and Apollo, and they just like blow my mind. They're so awesome. I can do things now I could never do before. I can write GraphQL queries in my client, and those GraphQL queries will still be resolved to REST endpoints. But some of those some REST points, and some of them will be GraphQL endpoints. And I'm like, whoa! So like as a front-end developer working in a big team, you can have some people responsible for making sure that the rest of the team can just write GraphQL queries, which is kind of handy for front-end developers, and they still get resolved to legacy endpoints. I think that's really powerful. So this is very like API consumer-friendly technology, right? So it's, but also I think API producer. If you are a backend developer responsible for exposing REST APIs to your front-end developers, and you're going to be super rigid about which things how to expose and everything, you're going to have a really busy job with like making these new endpoints the whole time, versioning them, making sure that that nobody sort of introduces stupid shit in your API that you then later have to unwind and everything. It's very process intensive. So I think it's driven to make consuming APIs more friendly, but I think in the end it's also more friendly to backenders because they have a very structured way of exposing their data. For me, it's like the self-documenting feature is really handy. I didn't really show it in the thing, but you can like document each type and each field, and you can basically say what it does and why it's there. And what's really difficult, I think, with working with many different APIs, is that you have to stitch results together. That's like something I've done so much in my life, and it's so error prone, where you have like events and then you query for like speakers, but some speakers there will be double, so then you make them unique, but then when you get the result back you have to then sprinkle them all over the place again on your it's like there's a lot of possibilities there for things to go wrong, and it's a lot of code that is now pushed to the server. And I think really efficient fetching is a really big win. Like it makes applications better on the web and on mobile applications. They just become faster. client-server decoupling. Yeah, and it's all because of types and relations. What I didn't talk about, which you probably might be interested in, is what sort of doesn't work well anymore, at least, is that HTTP caching is not an option. So because like REST integrates with HTTP, you can say like, so all gets on this thing will be, all gets on this URL will be cached for such a long time or whatever, or until it gets busted. And that makes it really scalable, REST APIs, because you can do really aggressive caching. That's no longer an option because GraphQL doesn't care about the transport layer, and therefore there's no URLs or anything. There's one URL, which is GraphQL, your GraphQL endpoint. But there's other ways to cache things. You can have application caching in the backend. You can have database caching. You can have and you have front-side caching. And a framework like Apollo, for example, makes it super easy to do that. You don't really have to think about it anymore. And it works better than trying to write it yourself. Mutations. So like what you have, like in REST, you would have this like get user /ID, and then you would guess like, oh, I can also put, and I can also post, and I can also delete. And that's not as discoverable now, because it might be that like, even though it's a user field to fetch it, what is it going to be told? It's to delete user, is going to be the mutation, or remove user. You really have to dig into the schema to figure that out. It's not hard, it's just not automatic. And like I said, you have to make sure that your resolvers aren't being stupid. And it's maybe not trivial even to write these things that resolve things in an efficient way. So as a conclusion, I think it is logical that as software developers, you want to keep moving, you want to build new stuff, and you want to like provide business value to your end users. And that means that things change, and that means you want to work with technology that facilitates these changes. And what I've tried so far, working with GraphQL at work, but also at home, is really fun to work with, and it really allows me to sort of I feel like productive and deliver a lot of value. So at least I think it would be interesting if you're like going to build an API, maybe to consider using GraphQL. Because it will probably be a good thing for you as well. That's it. That was long. Sorry. Any questions?
I have a question.
Yep.
You mentioned Facebook in the beginning of this, so I'm guessing this is all originating from Facebook.
Yeah.
I actually saw something about it on their website, if I remember well. Facebook, since a lot of years, has an API called Graph API.
Yeah.
Does that now use this query language?
No, it's a REST API.
Okay.
Yeah, it's confusing. They have a Graph API.
Are they going? Do you know if there's any plans in the future that they? Not that you know.
I don't know. No, I actually don't integrate with Facebook APIs, but it would make sense that they would do that. Actually.
It would.
But
Yeah, I think so.
Different.
Sorry?
Graph API is the actual API, while this is just a construct of simplifying the type dependency. I mean, they are not equivalent.
No. So one of them is.
You use Graph API in the back of this one.
Yeah, you could
provide a much better interface.
Yeah, you could. Like, you could literally just write your own GraphQL wrapper for this, and undoubtedly people have done so. Yeah. Probably.
I was especially wondering because Facebook went against the FQL, which they then later abandoned, so I was hoping that maybe this would be...
GraphQL is also literally a response to FQL, because so the FQL was basically allowing, they had this REST endpoints, and they had like to do a lot of stitching in the client, and they had many requests, and they figured, well, what if we could just let the front end just define their data need in sort of like a query language. And so they made something that looks very much like SQL. It's called FQL. And that was really powerful because you could really like get a lot of data exactly in the right shape in one query, and so it worked that well. But it scaled quite horribly in HR kind of way, because you would have these maybe 2-page long query statements written by front-enders, right? So then you need a front-ender that really understands sort of like this query language, and he's maybe 1 out of 10 in his team. So this like led to this sort of rock star kind of situations where you have this one guy who sort of is a full stacker, and he's like also responsible for like almost entire parts of the code because he's the only one who understands how the data works and how the query works. So that's why they invented GraphQL, is because it just broke down sort of their process development.
Yeah, SQL method dead end.
Yeah. Yep. Anything else? Oh yeah, so I think like because you guys all use like databases, I think one question I had myself, which I really didn't cover in this one, was like, so if you have all these resolvers that resolve fields, how are you going to do like are you going to like query for each field to the database? How is that ever efficient? You can like normally do one query where you join tables, do all those things, so you get a lot of data in one go. I don't actually know the answer to that, but I do know that there's a lot of like I think there's a bunch of frameworks that allow you to do this better. And what I'm also thinking is that like maybe actually it is still like efficient, even though you intuitively don't think so. Especially because like most resolvers, they run in parallel, so you get like parallel execution. Maybe it requires different types of database. MySQL wouldn't be able to do it or something. But this would be an interesting question for me, at least, like how do you make this resolve really quickly? At my current work, for example, we have a GraphQL server and it takes 8 seconds to resolve a query. I mean, that's unacceptable. So it does take work from like people implementing API and making sure it works efficiently. Yeah. If you have any questions, you can always ask me.
Why is it called graph?
Yeah, because like you could say is that when you have data entities that have sort of not recurring, but like have relations to each other in some way. So like a speaker has an event and the event has a talk and a talk. So when you get like a situation where like entities relate to each other, that's like a graph. That's just a
Venn diagram.
Yeah.
Well, Venn is with circles, right? So
But it's a graph. It's
yeah. So like, but this is like a graph is more like that. Like the with Venn diagram, sort of the joke is in like they overlap, and you have and like the title is like what the relationship means. But with the graph, it's more like the relationships are explicit, like what the relationship means. So that's why it's a graph, I think, because they say like, well, your data is like a graph. They could also have called it relational QL or whatever. It's I think they just really like the word graph because they have the social graph and the graph API and sort of their domain. Yep. Thanks, guys.
Thanks.
And girl.